Dear colleagues, ladies and gentlemen, thank you Siemens for inviting me to speak here today. I will be presenting preliminary data from this really fresh Piglet study with the hypothesis that Göran presented to you. The piglets were 5 to 6 weeks old and weighed 9 to 13 kilos. They were induced with sevoflurane, and the anesthesia was maintained with ketamine, fentanyl, midazolam, and pancuronium. We intubated with cuff tubes and gave them drugs and maintenance fluids through a peripheral line, had a carotid line for blood pressure and continuous blood gases, and a PA catheter through the jugular, also using that for central venous pressure. We ventilated the piglets on a servo eye and used a baseline ventilation of with an expiratory pressure of 6 centimeters of water, and adjusted the peak inspiratory pressure to 10 milliliters per kilo. It was in pressure control mode. The breaths per minute were 24. We had an IE ratio of 1:1. And the collapse mode was the same, but with 0 PEEP. And then we evaluated the open lung with CT scans every 20 seconds during the recruitment maneuver, and used the inspiratory hold knob for the recruitment and expiratory hold knob for the PEEP titration when we took the pictures. And in the servo eye, we have the possibility to continuously follow the dynamic compliance and the tidal carbon dioxide. We washed the pig's lungs with a saline to an oxygenation index of between 10 and 20, which promoted, it was a surfactant depletion to promote a tendency to collapse in the lung. And the recruitment maneuver we did like this. We started, as I said, with a baseline ventilation with a tidal volume of 10 milliliters per kilo and a PEEP of 6. And we moved to the recruitment phase. We started with 12 in PEEP and then increased the peak inspiratory pressure from 30 up to 45. And we stayed on 45 centimeters of water for 1 minute and then reduced the peak inspiratory pressure again down to 10 milliliters per kilo in tidal volume. And then we did the PEEP titration, going from 12 down to 5 or 4 even, exactly as we said before. And then we did a re-recruitment using the value from the recruitment period. We looked at the VTCO2 and took the best value there for as the new recruitment pressure. Used the same peak inspiratory pressure, and then we stayed there for 1 minute, and after that decreased the peak inspiratory pressure again down to 10 milliliters per kilo in tidal volume, and we set the PEEP, the the end expiratory pressure to 2 centimeters above the pressure that we found during the PEEP titration, where we found the collapse. There are very few data analyzed up to now, and this is, I'll just show you some small data number-wise. You can see here this line showing the overdistension, that it seems to increase between 35 and 40 centimeters of water. The VTCO2 compensated for the tidal volume seems to decrease during the same period. PaO2 increases continuously, and the compliance is quite stable. Nothing happens really there. And we see in this, when we have 5 animals, we see that the pressure actually goes down. This was actually nothing that we really observed as a blood pressure fall in the animals during the experiment. This was the recruitment phase, and this is the de-recruitment going from 12 in PEEP down to 4. And you see the collapse, the percentage increasing. Looks like it's starting to collapse a little here when we come down under 8. And we see that the dynamic compliance seems to go down at the same time as that goes up. And also the PaO2 follows the same curve. And this is easy to see when you have a continuous blood gas measurements as we had in this experiment. But this would be much more difficult to see when you have intermittent blood gases. And now I will try to take you through how it looks on the screen when we do this. We start with a baseline ventilation and move into the recruitment. We increase the peak end expiratory pressure, and we increase to 35, 40, and 45 during the recruitment maneuver, and goes further down now doing the PEEP titration. And we see now the compliance curve, which seems to be at this top and then going down. And now we are at 7, and we were at 8 there. Coming down and going back to a re-recruitment maneuver, and then stopping at 10 in end expiratory pressure, which was 2 above the 8 here. And we used for the re-recruitment maneuver 40 centimeters of water, which we found from the VTCO to the yellow line. The compliance is the white one. So looking at the compliance here, when we do collapse ventilation, we have 6.8, and then again a recruitment. We found the highest value here, and then coming down again, finding the highest value there at 9. Coming down and doing a new re-recruitment with 40 over 12, and finally ending up with pressures of PEEP of 11 and a peak inspiratory pressure of 17, and now the compliance is 18 instead. Showing you how it looks like the PEEP titration with more and more white lungs from this stage. And these are small videos. This is the sick collapsed lung. Going to the recruited lung. So there is the difference. So have we proven our hypothesis? It is important to say that this study is really preliminary, and the data are preliminary. We have not fully analyzed all data yet, but it seems to us that the dynamic compliance seems to detect collapse early. And we think it looks like the dynamic compliance is a valuable tool to recognize collapse. VTCO2 compensated for or corrected for the tidal volume seems to decrease when overdistension increase. The pattern is not as clear as when using dynamic compliance together with collapse. The blood pressure also seems in these circumstances to go down, but it's fairly small numbers and difficult to detect when you do the recruitment maneuver. We never had an impression of that we really had a blood pressure fall doing these maneuvers. both the blood pressure and the PaO2 needs to have indwelling artery catheters, but the dynamic compliance and the VT-CO2 can be seen on the ventilator continuously. Thank you for your attention.